All right, hey everyone. My name is Adarsh Shah, and I'm here on behalf of VandyHacks, presenting the Opensaurus-Rex Workshop that was initially supposed to be done in person, but due to changing circumstances on behalf of Vanderbilt, is now being moved online. Just a couple of things before we get started. Feel free to go on to learn.vandyhacks.org, and you can see all of these new links here. One of them for the Twitch, which is something that you're already on, and then we also have the Slack link just in case you need it. We also have a register at link, which has most of our setup documentation, which has been moved over here. So for dependencies, if you want to know how to get set up, just in case you aren't, go ahead and click on that link. There's also a link to our code or our GitHub, which we're going to be playing with today. And then finally, we have these slides present over here, which I'm going to be walking you through and understanding how open source software works. Great. So just to begin, let's go ahead and start our workshop. Welcome to the Opensaurus-Rex Workshop presented on behalf of the VandyHacks team. My name is Adarsh, and I'll be leading you through our presentation today. So the point of the Opensaurus-Rex Workshop is to be presenting a lot about, or understanding a lot about open source software, how to contribute to open source, and we're going to be using the Chrome Dino game to understand the different tools that we use to contribute to open source. So what are these different tools and what is open source to begin with? Just as an introduction, one of the things that we're going to be working through today is the Chrome Dino game. And you guys have seen this before. If you ever used Chrome and the internet's gone off, you've seen how if you press a spacebar, maybe you don't even know this, but if you press a spacebar, you're actually able to see the Chrome Dino game. And it's sort of an Easter egg, but you can also just go into Chrome//Dino and start playing the game. And this only works on Chrome. If you don't have Chrome, you can go ahead and copy this link off of the slides to access the Chrome Dino game. But essentially what's happening here is that we have this really cool Chrome Dino game, and you can just play with it for a little bit. It has features like a high score, and it's just this fun little mini game that you can play, and the idea is to avoid all of the sort of cacti, I guess, and there are different enemies later on in the game. But it's a functional game. If you die, you sort of get a game over status, and it's overall pretty fun, and it's cool to work with. So the goal of this workshop is actually to work with the Chrome Dino game and understand how to apply open source tools and technologies in order to actually do things like pull requests, work with Git and GitHub. And if all those terms are unfamiliar with you right now, it's no worries. But now that you're more acquainted with what we're going to be doing today, let's move on and understand what open source is to begin with. So open source is sort of in the name itself. It's something that's both open and it's something that you can often contribute to. So open source is really code that's free to edit, and it doesn't necessarily have to be code. Open source really refers to anything that's freely editable to any person. For example, when we apply it to this idea of programs and software, it's really going to be source code that's available to everyone. And a lot of great technologies that we have today are considered open source. So a couple of examples on the slide right now is Linux. For example, is a whole operating system that's open source. You can literally go to the Linux GitHub and start understanding what Linux is through its code base. There's also TensorFlow, which is going to be a machine learning framework library, which is very popular. That's open source. And we also have Python, which is a whole programming language that is considered open source. All these things are freely available on GitHub for you to use and also just explore and even make your own changes once you actually work with these different technologies and understand ways you can improve them. And the goal of this workshop is to be able to give you those tools in order to do those things. Probably some more topical things are even things like front-end framework. So if anyone does things like web development, Angular, Vue, React are all, and React, things like React Native for developing mobile apps, all these different things are considered open source technologies that are freely available for you to view and play around with. So what is version control, and why are we talking about it in terms of the context of open source technology? Well, version control is kind of separate from open source, but it's a way in which we generally structure our projects. So version control allows us to keep track of changes and record previous or multiple states over time. So what this means is, for example, is For example, say you were working on a Google Doc. Over time, you make changes, and if you go to the See Revision History on Google Drive or on Google Doc, you often see different states that are saved over time, which represent sort of different states or changes that you've made within the document, or in this case, it would be code. GitHub is very similar to Google Docs in terms of the fact that, Git is very similar to Google Docs in terms of the fact that it's a version control system. But generally, version control is something that helps you keep track of changes over time, so you can see when, for example, a bug was introduced, or where something went wrong, or maybe you want to revert back to initial version that you had made beforehand, and it's easy to do this through version control. So just through this meme over here, you can see that Google Drive is, again, a sort of version control system. And the analogy I made through Google Docs, for example, is something where you can make changes over time, and these are being tracked. Obviously, this isn't meant to be taken too seriously, but there's also a copy paste of a bunch of different folders, and like these are different version folders over time. It's a pretty inefficient way to do version control, but nonetheless can work. Version control can extend all the way to some very primitive techniques, such as what this is showing over here, such as like making different folders over time, or it can extend to more advanced version control systems like Google Docs, for example, or Git, which we're going to review right on the next slide. So what is Git and what is GitHub? Git and GitHub are often confused or sort of interchanged, but they're really two different things. Git is the version control system. It's what tracks those changes over time. So it's the thing that does version control. GitHub is really a website more broadly that actually hosts these Git repositories. It provides things like issue trackers, code review tools. It allows you to be very interactive and very social with your code. I like to think about it like sort of like a social media for all these different GitHub repositories. It makes it very collaborative, and GitHub has paved a lot of ways for actively contributing to open source over time. And it's a very important tool, and Git is a very important tool. GitHub is a very important website that developers use almost on a daily basis. So earlier I mentioned that Git is actually a version control system. There are very many different version control systems out there. Git just happens to be one of the more commonly used ones. But you can go ahead and see online about the many different version control systems that exist. So earlier I was talking about Git and how it's a tool for version control. But how do we actually interact with this tool? How do we install it? How do we do different things? How do we use it? So beforehand, we have posted this setup document, and you can follow along. Earlier on, you might have visited this link, or you might have actually had it installed onto your machine already, but this is how you actually can go access Git and configure Git. Of course, you can let any of us know in the Slack over here that's on learn.VandyHacks, or you can just go ahead and message the Twitch, and someone will be there to help you out. But essentially, the way in which we can actually interact with Git is through not only installing it onto our machine, but using something called the command line interface. So the command line interface is directly interacting with your terminal. So on Mac, the terminal looks like this. And you can see if I type in Git over here, it's going to show me a bunch of options on what I could do with Git. And we're going to talk about all these different things later, but there's things like git clone, git init, git add, git reset, git bisect, all these different really complex, also very simple Git commands that are so important in version control systems. So yeah, let's sort of walk through again what Git is. Git again is a version control system, and you can interact with it through the command line interface. So there are other ways you can actually interact with Git also. GitHub actually offers something called GitHub Desktop, which is a more nice framework. It's a very graphical user interface. It's a GUI for Git, and it makes it a lot more visual in order to interact with Git in the version control system. The command line tends to be more powerful though in the way that most people do it, but you can also have Git integrated with things like your IDE, as we'll see later in Visual Studio. So let's talk about these different operations in Git and what they actually do. Right? Git is the version control system, but how do we actually use it to do version control? So one of the main commands that are used is something called git clone. Git clone is what's responsible, as you can see here, to go to GitHub or to go get something from GitHub and actually clone it onto your computer or bring it onto your local machine. What does that mean? Well, on GitHub you have this repository, as it's called, or just think of it as a larger project, and you want to somehow make local changes to it on your computer. You want to get it on your system so you can make changes. How do you do that? You use git clone. That makes it such that it fetches that repository from that online source and brings it onto your computer. Now, once you have that onto your computer, you're going to be making a lot of different changes to it. And the way that you can actually start tracking these changes or essentially prepping these changes is through something called git add. Git add is something that will stage or essentially track these changes over time. So for example, if I change a file, I can simply add that file to be staged or tracked over time. Git pull is a command which will actually take those changes that are available on the github.com repository and bring that down to your local machine. So for example, if you have a local copy of a repository on your computer and there's already changes up in GitHub, you can say git pull and have all those changes be fetched for you automatically. Git commit is a way we can actually physically track those changes. So after we git added a file to be staged, right, git commit will actually stage those files over time and will track with a unique identifier what those changes are. That's exactly why there's a -m and write a message here, because it's expecting you to provide sort of a string or a bunch of words to describe those changes that you've made. And finally, we have git push. Git push will take all those local changes that you've done on your computer and will throw it all onto GitHub. It'll essentially push it back to GitHub so it's back online and all of your changes are published for the public to see. So those are kind of complicated and we're going to walk through all those operations, but just as a review, clone gets it from GitHub to your machine, add will actually track those changes, commit will actually stage those changes and label those changes, and push will put that back online. Great, so now that we have a little bit of an overview of what Git is, let's go ahead and start working on open sourcing and understanding those different commands and how they will work on your machine. So you can go ahead and click on the link here. It should also be on learn.vandihacks.org, but essentially this is going to be the HackPack, or essentially the boilerplate or the code that we're going to be providing you with today to play around with. So you can go ahead and look around in the repository. As you can see, there's a README here, a little bit of a GIF of what the game is, and sort of describing what I've already said. You know, what is open source, or what is version control? Why is version control useful? Git versus GitHub, the command line interface, and some suggested changes that we'll be getting into later. But the first thing to do is that, okay, there exists this repository online, but you want it to make your own. You want to make the repository your own. You want to start contributing to this existing repository that's on GitHub, which is exactly what version control is. So how do you do that? The first thing that you're going to do is something called fork, or forking the repository. And earlier on in the slides, there was an example of what forking does. So forking will actually get that repository from the original creator's GitHub and get it onto your personal GitHub account. So what does that mean? Well, you want to make changes to this repository, but you can't really do that right now because it's not necessarily on your account. You can't really track those changes over time. So all you have to do is press the fork button and clone it to, or fork it to, your personal GitHub account. And it's going to work. GitHub is going to work its magic. It's going to fork it for you. And now, as you can see, it's going to be on your personal GitHub account, right? And that's exactly what forking is. So now it looks like this is your own project right on your GitHub account, which is really cool. And you can see the README is all there. All the code is there, and it's very cool to see how you've almost made an entire project that already existed, and now it's all your own to make changes to. So how do we actually get this onto your local machine? If you'll recall from earlier, the way that we can do that is using git clone. So as you can see here, we have to use the git clone command, but of course this requires us to pass a link as an argument in order to actually get this onto our local machine. Where do we get that link from? Well, it's right here. As you can see on GitHub, there is a section here that says clone or download. And you can go ahead and click on this button over here to actually copy that link, and you can go ahead on your machine and on your terminal, wherever you feel comfortable cloning the repository. In my case, I'll do onto my desktop, and all you have to do is type in git clone and then paste that link, and it'll go directly onto your desktop. As you can see here, I have the Opensaurus-Rex HackPack. The next thing to be done is to simply go into that directory, and the way that you can do this is on a Mac is go to cd Opensaurus-Rex HackPack, and all you have to do is type in cd Opensaurus-Rex HackPack, and now you're there. You can type in the command ls to list out the different things that are currently on your folder, and we'll be reviewing all this stuff in just a second. But just to review, what you've just done is use a terminal to clone. Well, first what you did was actually fork the repository that already exists onto your personal GitHub account. You then cloned it onto your local machine. And now we're going to walk through some of the code. So the first thing that we're going to do is actually fix a bug together so we can understand more about all of these different types of Git commands that can be used in order to track those changes that you've made and push them back to a repository online. So the version control, the IDE that was recommended for you to use was Visual Studio Code. You don't necessarily have to use Visual Studio Code. It's recommended that you do so, but any IDE honestly would work perfectly fine. So all you have to do is open up your folder over here and drag this open to Visual Studio Code. And the way that you can do that is you can go to Visual Studio Code, press Open Folder, and you go to your desktop or wherever the repository is available, and simply press Open on Visual Studio. And as you can see here, there's the different files that are available. So just as a high-level overview, just to explain the functionality of the different files, you have an index.css file, an index.html file, and an index.js file. The index.html file is really going to be the structure of the web page. It's going to be the very bare bones skeleton. And this is very simple because there's not much going on in the web page. A lot of the functionality actually happens in the JavaScript file. And as you can see, this is actually 2,000 lines of code. It's a very big file. That's because this is a game, and it's very natural that there's a lot of functionality happening here. But don't get overwhelmed because we've actually gone ahead and labeled the different parts of the file that are pretty important. And then finally, we have the index.css file, which is pretty critical in order to do things like styling and understanding how to make things look better. Great. So let's start using version control and making changes to this file and seeing how we can put that back into your local GitHub account. So how do we do this? Well, the first thing that I notice is that you want to be able to actually run the code. So how do you run the code? All you have to do is simply go to the folder in which all the resources are available and simply double click on index.html. And over here you can see you have a pink version of the game, and you have a sort of a gray character and all these gray different sprites or characters that are available on your screen. It may look weird right now, but that's purposeful. That's one of the bugs that actually we would want you to fix through this workshop, is updating the color of the dinosaur and all the cacti that are available on the screen. But for now, you can see how this is a fully functional version of the Chrome Dino game, which is really cool. So after you've played with that for a little bit and seen the different things that you can actually potentially do with this, let's walk through one change. And this is going to be a really simple change, but it's meant to introduce you into this idea of version control and how we can actually edit these existing code bases. So the first thing that I notice is how I really don't like what the Chrome title is. Right now it says Chrome Easter Egg : T-Rex Runner. I don't really think that's too descriptive of what we're doing right now. So let's actually rename that. And to rename this, we're actually going to go into the index.html file, and this has already been labeled for you, but it says, as a comment, it says bug walkthrough, change the title of the web page. We want to go ahead and change the title of this web page. So how do we do that? We simply change the text that exists between the title tags in HTML, and let's call it, for example, Chrome Dino Walkthrough. if I save it and I press Command R or refresh the web page, regardless of what browser you're on, you should see that the title of the web page has been updated and now says something like Chrome Dino Walkthrough. Great. I've made these changes, but when I go back onto GitHub and I look online, I can see that that change has not actually been updated onto our index.html file on our personal repository. And that's kind of bad. I want people to see these changes that I've made because I am trying to improve the game over time, but this clearly isn't available here. How do I make that code that I just made locally, those changes that I just made locally, appear on to the index.html file that's available on my personal GitHub account? So the way that we can do this is actually go back to our terminal, and we can use a command called git status. So what git status is about to do is tell me the status of all my files, and it'll tell me what things have maybe changed and what things are maybe the same. So as you can see here, something that's been modified is the index.html file, and that's true. I just changed the index.html file to the Chrome Dino Walkthrough instead of what it was originally. So how do I actually add this? So remember or recall from earlier when we were looking at the lecture slides over here that adding is something that you can do in order to tell Git that you want these changes to be tracked over time. So right now index.html is not being tracked for changes, so we can simply do git add index.html. As you can see here, nothing was outputted in our terminal, but all we have to do is git status again, and we can see that over here we have now a green text and it says modified index.html. This means that the changes that we've made have now been tracked and are ready to be committed. Now, remember earlier we described how committing a file or committing a change or committing something means that we're actually labeling these certain changes over time. We're staging these changes and we're declaring this as something that's going to be tracked, and when we actually push it to GitHub, these are the distinct states that you'll see over time. So committing really just makes a different state that you can view your code in, and it's really a period of time or a point in time, and it shows what your code was like at that point of time. So all we have to do is say git commit, and we'll call this my first commit. Great. So now that we've labeled that, now that we've labeled this, all we have to do is we can see here it says my first commit has been made, and it says one file change and one insertion and one deletion. Okay, great, but when we refresh this page on GitHub under our index.html file, we can still see the changes yet to be made. Remember that the last step that you'll often do when you make changes onto local files in order to push them back onto your repository is do something called git push. Git push will now take those changes onto your computer and push them back to GitHub. So in order for GitHub to know that I made changes to my local Git repository, all I have to do is type in git push and I press enter. Now you can see all this weird complicated stuff over here, but essentially what that means is that if we refresh this page now, we can see our change has been made. But also you can see over here that you have an additional commit. Now there are 23 commits rather than there being 22 commits. What does this mean? As you can see here that you have made my first commit. It's labeled right here. All this stuff before that was changes made by the VandyHack's team, and it's their commits. Your own original commit is right here, and it says my first commit. And again, you can view the code within that, and you can even see changes over time that you've made. Of course, the red is what we've deleted, and the green is what we've added. And over here, you can even see the commit message, my first commit, and updated 1 minute ago. So that's the basics of how to track changes over time and what it looks like to be able to use the terminal and Git in order to be able to make those changes. Great. So now that we've made that initial change and we've fixed the bug together, let's go into a little bit of a work session here. So the content team on behalf of VandyHack has actually made a lot of changes to the existing Chrome Dino game. There are a lot of things that you can actually do to the existing code base that we've recommended to you, and the way that you can find this is by going to the JS file and doing //bug. //bug will, if you command F that or Control F, //bug, you'll be able to find places where you can actually change up the game and make it a lot fun or a lot more weird or make it your own essentially. So there are a lot of things that you can do. For example, changing the image of the dinosaur so it's pink. We've actually provided those assets for you. So as you can see here, there are pink assets available for you to actually change what the current Chrome Dino looks like, because right now it's actually gray, which doesn't really match the whole design of the current screen, which is largely pink. There's also other fun stuff that you could do, such as jumping or changing the constants, changing the speed, things like hiding the score so you can just mess with that, and changing the sound that is played when the player reaches 100 points, which is a little bit more difficult. But other than that, you can be creative. This is your file now. You can make any changes you want. You can push them all the way back to GitHub and make those changes viewable for the public. You can make any change you want, and it's really cool, and that's the idea behind open source. So, yeah. So just as a review as to what we did today in this session, we talked a lot about what version control is, what open source technology is, and so for example, just to review, open source is something that's freely available to the public and can be changed. And then things like version control are ways we can track changes over time, and we use Git primarily to do this. GitHub is going to be something in which we can actually host our repositories online and can actually add an easier experience to our version control, or essentially open source experience. It allows us to do things like fork current existing repositories, and is able to allow us to create personal copies of these repositories so we can make local changes to them and eventually push that back into GitHub so as to allow for local changes to be made over time. This allows us to be able to contribute a lot more to open source, and it's a really cool way in which we can build and modify existing code bases and make stuff that are really, really cool, just like the Chrome Dino game. So great, now that you've been empowered with all this information, go ahead and try making any of these changes, anything that you want. And while you guys are doing that, I will be walking through how to jump through the jumping and changing the constants that are available within the code, and show you the effect that has onto the Chrome Dino game that we are currently running locally over here. Just in case you want to do something more interesting on your own, you can go ahead and mute me and work on your own. But I'll be walking through jumping and changing the constants right now. And feel free to ask any questions on the Twitch or the Slack. But yeah, so what I'm going to be doing right now is changing some constants just to make this a lot more whack. So for example, here is where gravity is. Gravity is a constant that essentially controls how high or how high on the y-axis our dinosaur can actually jump. So right now it jumps pretty regularly. It kind of seems like it's emulating gravity on Earth. But let's see what happens when I change it to 0.1. Yeah, so it takes a lot longer for our Chrome Dino to actually respond. As you can see, when we decrease gravity, it's able to jump kind of like it's on the moon, which is pretty cool. But what happens if I change this to maybe 2.0? As you can see, it's really difficult to actually get off the ground. And yeah, I don't even think it's possible to jump over the cacti. So let's set this back to maybe 0.4 and see what happens. I get a bit of a higher jump, and I think that's pretty cool. Let's see if there's anything else we can change. Speed is another value we can change. So currently it's set at 6. Let's set it back to 1. Okay, so now it's really slow, and it's kind of boring actually, because this is going to take forever. But what we can do is we can actually change the speed to 10. And you can see that the speed actually increases so much more. And this actually creates a very difficult game now. Oh, I lost. But it's a lot more difficult to play the game now because of the changes that we've made. Not only did we decrease gravity just a little bit, we've also made the game go a lot faster. So it creates a little bit of a weird game there. And let's see if there's any other bugs that we can fix. We can also fix the distance in meters. Right, so what happens if we change height to, for example, 100? As you can see, our game goes completely whack because we've changed so many constants now, and it's kind of fun to see how it's kind of bugging out over here, as you can see in the right hand side. So let's change those, make that change back again, and you can see we kind of have a functional game. But yeah, you can make all these different changes. These are just some suggested changes, but you can also go through the entire code base. It may be a little bit difficult at first, but you can see where all the math is done in order to control how things like jumping or walking even, or sorry, running is changed, and yeah, how things like drawing the score is done, things like that. All of these are controlled in the JavaScript portion of the code, and most of this is controlling the functionality. And it's really cool to see how all this comes together, and maybe, for example, if you changed a couple of things, for example, let's make a very random change over here. In this constant over here. Let's say this dot x is this dot y. We set that equal to x for whatever reason. Maybe nothing might happen. It looks like this is the collision box over here, which may affect how we actually collide with objects. But here, for example, you can change the parameters of how you collide with things. This is a collision box system, so there's different boxes wrapping different objects on the screen that allow you to detect when these different boxes collide together, so you get an actual game that you can play and lose in. But yeah, so these are the different changes that you can make. Feel free to go anywhere within the code base, make any change that you want, and just see what happens is the coolest part, really. So here I kind of changed something random with the cloud, and I don't really see anything immediately happen. Oh, actually it looks like I just lost there. So I don't really know what's happening now because I've changed so many different things. But yeah, let me just go ahead and now practice this one more time, but we're going to git status, and we can see that we've changed primarily the index.js file. We can go ahead and say git add that index.js file, and then we can go ahead and commit the changes that we've made, and so far we've made some very random changes that affect the game. And then we can go ahead and push this. And as you can see back on your repository, the changes have been made where it's very random changes that affect the game. Great. Yeah, so now that you have a better idea of what open source is, how to use Visual Studio to actually modify your code, how to go into Git, GitHub, version control, all these are really important tools to empower you to contribute to open source software. And going onto GitHub and understanding, going onto the Explore page and understanding the different things that you could do online, and it's really boundless, essentially. You can go in all these different projects, understand what interests you, and use these tools over time and hone these skills in order to understand how you can be a pretty cool contributor to open source. Yeah, so thank you so much for coming to the workshop. I hope you enjoyed it, and I'll see you next time.